Hello, my name is Gloribel Vázquez Cornejo. I am currently doing a PhD in water safety at the Mexican Institute of Water Technology, located in the state of Morelos, Mexico. The research topic that I'm going to present is HYDROTALCITE composites modified with zirconium-4 and iron-3 in different molar radius for the removal of fluorides from water. The main objective of this research is the removal of fluorides with adsorbent materials of the type of lamellar double hydroxides, or commonly called a hydrothalcite, in which the effect of the modification of the structure with tetravalent zirconium and trivalent iron was studied to modify its properties, causing a greater removal of fluorides from water. The research is aimed at remediation of groundwater, since it is the water for human use and consumption. Fluorides dissolved in water cause various diseases, such as skeletal and dental fluorosis. Therefore, the search continues for alternatives and technologies that help us mitigate this environmental problem that affects the whole world, especially in arid and semi-arid regions. Mexico is no exception, as this problem is exacerbated in the northern part of the country. These adsorbent materials called hydrothalcite are synthetic compounds of metallic hydroxides, structured in positively charged layers that are stabilized by a strong electrostatic interaction with anionic species between the layers. When calcined, they tend to present a memory effect where hydroxyl groups, water molecules, and carbonides are eliminated, causing a collapse in the structure. However, when placed in contact with anions of interest, in this case fluorides, it has the ability to revolve itself and absorbs them on the surface of the materials, thus eliminating them from the aqueous solution. Methodology. This section consisted of synthesizing by the co-precipitation method, which is a gradual addition of a metal solution and an alkaline solution and then subjecting the mixture to ultrasonic agitation, followed by aging, and then washing to obtain a neutral pH in order to eliminate soluble compounds. Finally, it is dried and calcined to obtain a white powder, as seen in Figure 2. Hydrothalcite is composed of magnesium and aluminum cations in the layers in a ratio of 3 to 1 molar respectively. Therefore, in the modification, it was proposed to integrate zirconium into molar radius of 0.1 and 0.05 molar. And in the case of materials modified with iron, the ratio of 1 and 0.8 molar. The structure, morphological, and physicochemical characteristics were observed by means of X-ray diffraction, energy dispersed X-ray spectroscopy coupled with scanning electron microscopy and nitrogen physisorption, which using the Brauner-Emel-Thaler method, obtaining the specific surface area of each material. Then, the absorption process was studied through preliminary tests. A design of experiments was carried out using the response surface method and absorption kinetics. We move on to the discussions and results section, in which the results of the characterization of the materials are present, where in the X-ray diffraction, Figure 3, the characteristic reflection of the hydrothalcite phase are observed, independently of the proportion of zirconium and iron. However, the crystallinity is affected by the greater quantity of zirconium and the incorporation of iron. It is observed that the crystallinity decreases, and this effect in the case of zirconium can be attributed to the formation of another phase, possibly to zirconium oxides, which is confirmed by the result of the EDS and elemental mapping, Figure 4, where a greater dispersion of zirconium is shown in zirconium 0.1 than in zirconium 0.05. The same tendency is observed with the results of a specific surface area. Since zirconium 0.05 has a greater area with respect to the other materials. On the effectiveness is reflected in the removal of fluoride, which was higher with the zirconium 0.05 material, as observed in graph 5. Upon finding the most efficient material with good properties, the optimization process continued, for which an experimental design was carried out. Figure 6, where the optimal absorption conditions were an initial fluoride concentration of 12 milligrams per liter, an absorbent dose of 1 gram per liter, and a pH of 7. 98% removal was achieved with an absorption capacity of 12.58 milligrams per gram. Then the equilibrium time was studied by means of absorption kinetics, figure 7, where at 180 minutes, 99% removal was obtained. They were evaluated by mathematical models to know the nature of the process, and the data were adjusted by the pseudo-second order model, where possibly a chemist's absorption follows and that the absorption. Conclusions are that hydrotalcite modified with zirconium with a molar ratio of 0.05 molar effectively removes fluorides from water. However, to establish conclusions about the absorption process, research continues with the study of isotherms, thermodynamics, and regeneration. In addition to test with groundwater from the state of Morelos, it is also intended to investigate the formation of pairs support with the material zirconium 0.05, which was not as efficient in order to pack it in a column and study the behavior in a continuous flow system. Thank you so much for your attention.